Hello, and welcome to Algebra 2 main lesson. Um, there's nobody here. I get it. Blackboard's not working today. I was lucky that I loaded my e-sessions in early this morning before Blackboard went down, so I still have Blackboard. I'm going to go through all of the material just like I normally would. Remember, we do have a help session on Wednesday, so if you have any questions, please make sure that you watch this very carefully because I'm going through some problems that are the exact problems off the assessment for this week. All right. We are going to be solving equations. This is stuff that you should have learned back in Algebra 1. Now, back in Algebra 1, you solved equations, linear equations. This year, we're going to be solving a linear and a quadratic. They're solved exactly the same way. There's three methods to solve. Graphing is one, substitution another, elimination is a third way. And when I did this in Algebra 1, the students, the graphing method is easy, and you do have to show your graphs this week on the assessment. So if you don't have graph paper, please use the Jamboard because it is a great way to have the piece of graph paper ready there. But when you solve a system by graphing, all you do is you graph it out, you find out where it crosses the x-axis, or I'm sorry, not where it crosses x-axis, you find out where the two lines cross, and that is your solution. Now, it stays the same, especially, we're going to have like a quadratic and a line, so we might end up with two solutions if it crosses twice. Now, you could have a parabola and a line that never cross, so there would be no solutions, or you could have a parabola and a line that just touches in one place. So you could have zero solutions, you could have one solution, you could have two solutions, and by graphing, you should be able to see how many solutions you have. Now, let's try a problem off of this week's assessment. This is an exact problem. Now, it puts a couple things together here. Remember a couple weeks ago, we were talking about graphing quadratics, and when we were talking about graphing quadratics, we used vertex form, and it told us which direction it moved, left and right, and how far it moved up and down. Okay, I believe this is a -4 here. I really can't see that. I think that's a -4. I'm hoping it's a -4 in there. And I can't get back into my Blackboard, so I can't see it. 1 second, I might have, because I did save it in my thing here. So maybe I can tell, because I want to make sure I do the right problem here for you guys. Let's see here. I put it here. Okay, so which one did I pick? I took this one. Yeah, I think it's a -4. Okay, so let's go -4 here. So I'm going to solve this system of equations by graphing. Well, let's review graphing a linear function. This is a linear function, it's a straight line. This is the slope. So I have a slope of 2. So I just put it as 2/1. And my y-intercept is 1. So if I was going to graph this, I go over to 1 on the y-axis, and then my slope is 2, so that tells me to go up 2/1, up 2/1, and I'm going to go down 2/1. So I have a good line here. And there's my equation of y is equal to 2x plus 1. All right. Now I'm going to graph my second equation. I'm going to do it in a different color. Y is equal to x plus 1 squared minus 4. Okay. So remember, this is a parabola, and it's going to be shifted over. It's going to be shifted down 4 units, down 4, and it's going to be shifted one place to the left. Remember, because if it's a +1, it's shifted over. So I'm going to shift over 1 to the left and 4 down. 1, 2, 3, 4. And then a parabola. Hopefully you remember this from Algebra 1. The pattern for a parabola is 1, 3, 5. So I go over 1, up 1. Over 1, up 3. 1, 2, 3. Over 1, up 5. 1, 2, 3, 4, 5. And then this way I do the same thing, over 1 up 1, over 1 up 3, over 1 up 5. So my graph looks like this. Now my solutions are where it crosses the graph. Well, it crosses here and here. So it looks like my solution is -2, -3. And this point here, I think it looks like 2, 5. So that is solving a system of equations by graphing, okay? And all three of the problems on the graphing portion of it are in vertex form. So you don't have to worry about any other type of problems. And you do have to show your work. You have to show your graphs. So please make sure you show that work. And then your solutions would be written down here, -2, -3, and 2, 5. Okay, so those would be my solutions. So that's one way of solving a system of equations, is by graphing. The second method to solving a system of equations is called the substitution method. Now, in the substitution method, when we used to use linear equations, as long as we knew what one of the variables was equal to, okay, so in this problem, I know what y is equal to. Now, this is substitution. If I said y is equal to 2, and then I gave you an equation like 2y plus 5 is equal to x or something like that, and I said solve for x, you know what y is equal to. It's equal to 2. So you'd substitute it in here. So you'd rewrite this as 2 times 2 plus 5 is equal to x. So 4 plus 5 is equal to x. So x equals 9. That's substitution. When you know what one thing equals and you plug it back in, that's substitution. So in this problem, I know what y is equal to. It doesn't equal a number. It equals this. It equals 2x plus 4. So wherever I see y in the second equation, I put what I know y is equal to. I know it equals 2x plus 4. So I'm going to rewrite this as 3x plus 2x plus 4 is equal to 9. And then I just solve this. So 3x plus 2x, that's 5x plus 4 is equal to 9. Bring the 4 over. So 5x equals, what is that? 5. X equals 1. That is called substitution. So let's try a problem off this week's assessment. Okay, so now, oh boy, I have a quadratic and a linear function. But it says that I have to solve it by substitution. So if you graph it, you're not going to get any points. You have to use substitution. So I know what y is equal to. Y is equal to 3x minus 2. So in the first equation, I'm going to plug in 3x minus 2 in for y. So I've got 3x minus 2 is equal to x squared plus 5x minus 2. Oh no, this is a mess. The one thing you have to remember, when you're solving a quadratic, it has to be set equal to 0 in order to solve. So what I'm going to do is I'm just going to subtract 3x off of both sides. And I'm going to add 2 to both sides. I want to get that side equal to 0. So now this side 0 is equal to x squared plus 2x plus 0. Oh, okay, that's not bad. So now I have x squared plus 2x plus 0, which I don't have to equal 0. So how can I solve this? I could use a quadratic formula. I'm going to factor out an x. And then I end up with x plus 2 equals 0. So what are my solutions? Well, if you ever factor out something, this has to be, 0 has to be a solution. So 0 is a solution. So x equals 0 is a solution. And x, what makes this equal to 0? -2. Now, those aren't my solutions. Those are my x values. Remember, a solution is an ordered pair. So I know 0. So now how do I find my y value? Well, you can take either equation and plug 0 in. So let's put 0 into here because that's way easier. 3 times 0 is 0. So y is equal to -2. Now, if I plugged it into the top equation, I should get the same thing. So if you put 0 here and 0 here for x, 0, 0, minus 2, I get the same thing. Then I want to find out what my solution is at -2. So I put -2 in here. So y is equal to 3x minus 2. Oops, minus 2. So I'm going to put -2 in here. So 3 times -2 is -6. Minus 2, that's -8. So my second answer is -2, -8. Now, how can I check myself? Yeah. How about Desmos calculator? Plug it into Desmos and see if it crosses at 0, -2, and -2, -8. Now, that is a check. That is not your your work. This is your work. I need to see this. But can you check your answers tonight? Oh yeah, every problem can be checked on Desmos calculator because you can just graph them out, find out where they cross. And if they don't cross at the same spot you came up with, you did something wrong with your algebra. Go back and check it out, because Desmos is such a great tool that you should be able to use it to check your answers. Okay, and I'm not saying it's wrong to check your answers, because I definitely would. Okay, and then the third method is called the elimination method. Now, when I taught algebra, I used to call this the addition method. Okay, because you're gonna, like, for example, if I had 3x plus 4y is equal to 10 and negative 3x plus 5y is equal to 20, I would add straight down because one of the variables is going to cross out. That's called the elimination method. We're eliminating one of the variables. So 3x plus negative 3x at 0, 4y plus 5y is 9y is equal to 30. Divide through by 9, you end up with y is equal, I just made this problem up so it wasn't very nice, but then you have to figure out what your x value is. So that's the elimination method. So let's try a problem with the elimination method here. Now this one's a little bit tougher. I'm going to eliminate the y's here, right? But if I add straight down right now, the y's aren't going to cross off. You'd end up with 2y. So what I'm going to do is I'm just going to multiply through by negative 1 on all of these, because then I can use the addition method. So I'm going to just multiply by negative 1, so that becomes negative 1. This becomes positive 12x. This becomes negative 36. So now if I add straight down, the y's cross off, so I'm left with 0 is equal to, well, x squared, there's no other x squared, so I'm just going to leave that. Then I've got negative 11x plus 12x. Well, that gives me 1x. I got negative 36 plus negative 36. That's negative 72. Ah, okay, so now I have a quadratic. I'm going to solve this by factoring. You can solve it any way you want. You could use quadratic formula, completing the square. Really doesn't make any difference. I'm going to factor this. What two numbers multiply to negative 72 that add up to 1? Well, x plus 9, x minus 8. And that means x equals negative 9 or x equals 8. I'm not done, because remember, our answers are ordered pairs. So negative 9 is my x value and 8. So how do I get my y value? Well, you just got to plug this back in. So, and I'll let you guys see that, because I'm looking at this twin negative 12 times negative 9, blah, blah. But then how do you check yourself? Graph it out. Desmos. It's going to look something, it's going to cross. So you just have to look at where it crosses. Those are your solutions. All right, now the next step would be to go to Desmos presentation. However, there's nobody here. Why isn't there nobody here? Because Blackboard doesn't work. So I'm going to go through the problems myself for you guys. Okay, so what I'm going to do here is I'm going to share my screen here, because I still have Desmos. Oops, that's not exactly what I wanted to do. So I want to share the application screen. So I want to share. Okay, so this must be it. Okay, so here we go. Problem number 1. We on the practice this week, and I think there's only 7 problems, and I couldn't check myself because I went through my Desmos presentation and I only had 7 problems on there. But then it's like, oh, I'm going to go check myself to make sure I didn't forget to put any problems on there, and I couldn't get back into Blackboard. So I'm not able to check. So I'm hoping there's only 7. All right, so in this problem here, it says, how many points are there which satisfy the system? Y is equal to, okay, so I'm just going to write this out. Y is equal to x squared minus 6x plus 8, and 2y plus x is equal to 4. Now, there's no way to figure out how to do practice problems. If I was going to do the practice problems, I'm just going to throw it into Desmos to get my answer. So, and remember, we could have no solutions, 1 solution, or 2 solutions. So I know D can't be right. You can't have an infinite number of solutions when you're dealing with a quadratic and a linear function. So I know there only is 1. So now I have to go back. I have to turn off that sharing, and I have to share another different application here. So I'm going to share my Desmos graphing calculator. Okay, So now you guys should be able to see, I just graphed out x squared minus 6x plus 8 and 2y plus x equals 4. It did not ask for the solutions. The solutions are where it crosses. It just asked how many there were. Well, I can see plain as day that there are 2 solutions. So my solution to this problem is going to be letter C, okay? Because it's going to be, now I'm jumping back and forth from screen, so now I have to get back to decimals. So I'm going to share the screen. Okay, so now the answer should be 2 for that. Okay, because it has 2 solutions. And then that's all it asked me for. Didn't ask me to solve, just asked me how many solutions there are. Okay, let's go to problem number 2 on the practice. Number 2, it says, what value of x satisfies the system of equations? So what value of x? Okay, so now I'm looking at this, and to me, I know how to graph this out pretty easily. Okay, I'm looking at this, x squared, that is a parabola that looks like this. Okay, I don't have any graph paper. I should have put a piece of graph paper on here. Probably would have helped. And then I'm going to graph 2x minus 1. So that means my y-intercept is -1, and my slope is up 2 over 1. All right, so it's going to look something like that. So what x value does it look like? To me, it looks like x equals 1. All right, so I am going to leave that as x equals 1. Now I'm going to check myself. I'm going to just put it in here because I know my y value has to be exactly the same. So if I put 1 in here, I end up with y is equal to 2 minus 1, which is y is equal to 1. If I put 1 in here, 1 squared is 1. It's the same. So this point here is 1, 1. So I know my x value is 1 for my solution. Now I could have used decimals calculator to solve that also. Okay. All right, it looks like Blackboard is working again. You guys are going to have to go back and watch the beginning of this because I did not want to not have a presentation for you guys. So I started with it. So you might want to, and if we have time at the end, I will go back and go through what I went through. But I don't want to do that because I want to make sure I get through all of the problems that we're dealing with. Okay, I just want to make sure there was only 7 problems off the practice. Did I properly explain how to figure out the second solution in these systems if there is one? I don't know what that means. There's when you start working with Renee, you can go back to problem number 1, and if I have time left over at the end, I will go back to it. Oh boy. Okay, I'm gonna. Oh, I know. Blackboard was down for everybody. Parabola can intersect with a line twice. There is no doubt a parabola can intersect with a line twice. You would have 2 solutions there. Yes. All right. Let me go back to the beginning. Hopefully we'll get through all of the problems here. Okay, so I got to turn off this. Go back to my normal slides. Okay, so this is, nope, that's not right. That is not the set of slides that I wanted. All right, so let me get back here. Week number 7, is this the right one? Okay, that's the right one. All right, so I started, and some people are they're gonna go nuts because they're gonna watch this presentation and it's gonna start all over again. And they're gonna be like, what the heck is happening? Okay, so when you're solving a system of equations, this goes back to Algebra 1. Algebra 1, you should have learned how to solve system of equations by graphing, by substitution, and by the elimination method. Okay. Now, in Algebra 1, we only found solutions of systems of equations with linear functions. We did not spend any time dealing with quadratics and linear functions. But the method is exactly the same. The method is exactly the same for finding an answer using graphing or system of or by substitution or elimination. Okay. So when you graph, and what we did in Algebra 1 is we just graphed linear functions, and where the two lines crossed, that was our solution. And we'd end up with one solution. Now, we're going to use the same method to this week, graphing. And this is a problem that is on your assessment this week. Okay, I guarantee you this is a problem, and you have to graph this out to find the solution. Okay, so now let's review. When you graph a quadratic, it looks something like this, right? We graphed quadratics before, it's parabola. And let's say I graphed a linear function. Well, guess what? It could cross twice. So you could have two solutions. Or you could graph it and it might only hit once, and you'd have one solution. Or you could graph it out and it might never hit. So you could have no solutions. Okay, so those are your choices tonight. Well, it's not really a choice. It just that's how it could happen. You could have no solutions if it never crosses, or if it never touches. You could have two solutions, or you could have one solution. You can never have an infinite number of solutions, just 0, 1, or 2. Now, how do I know that? I know that because the second degree here tells us how many solutions we could have. That is the total number of solutions you could have. Okay, never could be any more than the highest power. Okay. Yes, you are not using Desmos tonight. Can you use Desmos to check yourself? Absolutely. But you have to graph it on paper. Or you can use the Jamboard and do it on that piece of graph paper. Okay, so how do we graph this? Remember, this number tells us how far up or down I go. So I know I'm going to take my parabola and I'm going to shift it down 4 units. And this tells me that I have to shift it over one place to the left. Okay, so my parabola is going to look like this. I'm going to shift one place to the left, 4 units down. That's where my parabola is going to start. Okay. Yes, exactly. You have to graph these two equations to show your work. Yes. Okay, now how do we graph a parabola? Remember, the pattern is 1, 3, 5. So from my vertex, I go over 1, up 1, over 1, up 3, over 1, up 5. I do the same thing on the other side. Over 1, up 1, over 1, up 3, over 1, up 5. So there's my parabola. I've just graphed it out. Okay, so now I graphed the parabola, but I didn't graph the other one. So let's graph the line. Y is equal to 2x plus 1. Well, in order to graph a linear function, I need to know what the slope is, and I need to know what the y-intercept is. Well, it's in slope-intercept form. The slope is 2, so I write it this way, 2 over 1, and the y-intercept is 1. So now if I was going to graph it, I put a point at 1. That's the y-intercept. And my slope is 2. So from this point, I go up 2 over 1, up 2 over 1, up 2 over 1, and I could go backwards 2 over 1. Why am I doing it this way? Because I want my graph to have a lot of points. So when I draw my line in, I've got a good line. So there's my graph. my graph is my work. It's not my answer. My answer is where the two lines cross, okay? So my line, my answer to this problem will be -2, -3. That's 1 point. And my other point is 2, 5. That is a solution to this system of equations using graphing as my method. Okay? So that is, and that problem is on the assessment tonight. Solving that system of equations by graphing. Well, you might want to, well, it's recorded, so you can see the recording. All right. Now, the second method that you should have learned in Algebra 1 is solving by substitution. Now, if I gave you something like this, and I said, okay, if you had y is equal to 2, and 2x plus 3y is equal to 4, and I wanted you to solve for x, you would take this y is equal to 2 and you'd plug it in for y, correct? And then you'd go 2x plus 3 times 2 is equal to 4, and 2x plus 6 is equal to 4. You subtract the 6 off. This is what's called substitution. When you know what something is equal to, you substitute it in. Well, when you have a system of equations like this, I know what y is. It's 2x plus 4. Now, some kids are going to say, but that's not a number. It doesn't have to be a number. When you use the substitution method, you substitute what you know one of the variables is equal to. So I know y is equal to 2x plus 4, so I'm going to plug it in right here. So I'm going to rewrite this as 3x plus, and instead of y, I'm going to put in 2x plus 4. Okay? And then I would solve this. 3x plus 2x is 5x plus 4 is equal to 9. Subtract that off. 5x equals 5. X equals 1. That's one of my points. X equals 1. How do I find my other point? Plug it in to one of the equations. Doesn't matter which one. So if I put 1 here, 2 times 1 is 2 plus 4 is 6. So y is equal to 6. That is the method that you should have learned back in Algebra 1. Now, this problem is off your assessment also. Okay? And you have to use the method of substitution to solve. Okay, now this is a little bit tougher. I've got a quadratic and a linear function. Oh no, this is way harder math. Okay, but the steps are the same. So we're going to take, we know y is equal to 3x minus 2. So wherever I see y in the first equation, I'm going to put 3x minus 2. So I'm just going to rewrite this as 3x minus 2 is equal to x squared plus 5x minus 2. Okay. That is substitution. Now, I didn't solve anything yet. Okay. But now this is a quadratic. How do I know it's a quadratic? You've got an x to the second power. How do we solve a quadratic? We set it equal to 0. So I'm going to subtract 3x from both sides. I'm going to add 2 to both sides because that'll leave me with 0 on this side. So I'm going to subtract 3x here. I'm going to add 2 here. So I'm left with x squared plus 2x plus 0. Okay, so now I've got it in the form, quadratic form. I could use the quadratic formula to solve this. I could factor it if I wanted to. I could complete the square if I wanted to. I looked at this and I thought, what if I just pulled out an x? That leaves me with x plus 2 equals 0. Anytime you factor something out and it's a variable, one of your solutions has to be 0. And then what makes this equal to 0? -2. So my two x values, or for my solutions, I know x is 0. I don't know what the y value is. And I know x is -2. I don't know what my y value is. I can't stop right now. I have to continue on. So I'm going to put 0 in here. So y is equal to -2. Why did I use this equation? Just because. I could have used this one. I could put 0 in here. 0 squared plus 5 times 0 minus 2. That's -2. Get the same answer regardless of which method I use. I mean, it doesn't make any difference. And then I still have to solve for -2. So if I put -2 in here, so 3 times -2 minus 2, so that would give me -8. Now, that is the work that I'll be looking for this week. How could you check your answer? How could you check your answer? Decimals. That's exactly right. If you graph this out and it doesn't cross at 0, -2, and -2, -8, you did something wrong. Okay? And is checking your work a bad thing? I don't think so. I think checking your work is an awesome thing, but you do have to show your work for these problems. And if it says solve it by using substitution, you need to use substitution. If it says solve by graphing, you've got to graph it. And I will have a piece of graph paper there so you can graph your function out there, but you can check your answers. I mean, this is one of those weeks where, you know, all of your answers can be checked using Desmos. I will tell you that you won't get any credit, though, if you do not show your work. Okay? All right. The third method of solving is called the elimination method. Now, I used to call this, and I still do when I teach Algebra 1, I used to call this the addition method. Why do I call it the addition method? Because usually what you do is you add straight down to get rid of one of the variables. For example, if I had something like 3x plus 4y is equal to 10 and -3x minus 2y is equal to 20, and I wanted to solve this system of equations using the elimination method, I would just add straight down. 3x and -3x crosses off. 4y minus 2y gives you 2y is equal to 30. Divide through by 2, I end up with y is equal to 15. Well, that's pretty cool. It just crossed off. Well, the method is the same when you are dealing with quadratics. Yep, then you just plug the y into the y value into one of the equations to come up with your x value. That's absolutely right. Yes, exactly. Okay, so now let's say we had something like this. Oh boy, can I use the elimination method here? Yeah, you can. So what I'm going to do is I'm just going to write this out. I'm just going to write y is equal to x squared minus 11x minus 36. And I'm going to write y is equal to, and I'm going to line these up, -12x plus 36. Now, if I add it straight down right now, neither of the variables are going to cross off. Okay, the x is not going to cross off, the y's are not going to cross off. So you should have learned in Algebra 1 that you can multiply, right, you can multiply any of the equations by something. I'm going to multiply by -1. I'm going to multiply this equation, the whole thing, by -1. Well, what does that do? It just changes all the signs. This becomes -y. This becomes positive 12x. This becomes -36. So now if I add straight down, lo and behold, the y's cross off is equal to x squared. What is that going to be? Plus 1x minus 72. Oh, how can I solve this? Complete the square. I could use the quadratic formula. I like factoring. What two numbers multiplied in -72 that add up to 1? Positive 9, -8. So x plus 9, x minus 8. So my solutions are whatever makes the parentheses equal to 0. That would be -9 or 8. Sure, I can do that. So now I have my x values, -9 and 8. I still have to solve, for my y value, right? I got to find out my y value by just plugging it back in. I'll let you guys do that. But somebody asked if I could show to solve it by completing the square. Okay, so here, so we were down to this point, and I want to solve by completing the square, okay? Because that's what we did last week, right? So I'm going to rewrite this as x squared plus 1x plus something is equal to negative 72 plus something. Oops, plus something. This is not going to be nice. And why am I going to say that? Because what is half of 1? Half of 1 is 1/2. Square it, you get 1/4. Oh, yay, this is starting to become not so nice. That's why completing the square sometimes it's not the best way of doing it. It does work. So now if I factor this, I get x plus 1/2 squared is equal to, what is that, negative 71 3/4. Okay, so now you're dealing with fractions. Oh boy, I don't want to deal with taking the square root of this thing here. I mean, this one's not bad. You get x plus 1/2 is equal to, I don't know what the square root of 71 3/4 is. And it's negative. No thanks. Oh, that would have been positive. I'm sorry, because if I would have brought 72 over, it would be positive. So this would be positive 72 1/4. And then trying to take the square root of that, no thank you. That's but you're going to get the same answer regardless, but that is not an easy way of doing it. And if you use the quadratic formula, same thing. I mean, you're probably not going to get a really nice answer oops, now I forgot what I had. What was it? X squared. X squared plus, is that 1x minus 72? Is that right? Yeah. And then if I use the quadratic formula, a is equal to 1, b is equal to 1, c is equal to negative 72. So, negative b, so you got negative b plus or minus 1 squared, which is 1, plus or minus, I'm sorry, minus 4 times a times c, so 4 times 1 times 72. Not exactly sure what that's going to be, but it does work. I mean, you could do it either way. I would highly recommend just sticking with, factoring if you can. But if you can't, you can go to any method you want. I would also say to make sure that you plug this back in. Did anybody plug this into Desmos? Both those equations? Because it should work out. I mean, you should get, the graph should work. Okay. Can I redo the factoring? Oh, okay. Factoring, you have to look at, when you factor, remember you have to look at the last number, and you have to ask yourself what two numbers multiply to give us this, but add up to this. Well, negative 9 times 8 is negative 72. I'm sorry. I want to go positive negative. That's negative 72. Positive 9 plus negative 8 is equal to positive 1. And that's my middle term. So now I know what my two numbers are. So it's x plus 9, x minus 8. Once you have it factored, it's whatever makes inside the parentheses equal to 0. So that's negative 9, positive 8. Okay. Now, I want to scoot along here because we're not going to get all the practice problems done. And that is not, we want to make sure we get all the practice problems done. So let me go to share here. I think this is right. Okay. So I already did problem number 1. Okay. It came out, and I did it on Desmos. And you can go back and you can watch the recording. It comes out like this. The parabola looks like this, and then the graph looks like this. So it asks, how many points are there which satisfy the system of equations? Well, you could have 0, 1, or 2. That's all you can have. when you solve a system like this, when you have a linear function and a quadratic. You could have 0 solutions, you could have 1 solution, you could have 2 solutions. Well, I graphed it out. I saw right away that I'd have 2 solutions, okay? Now, the practice doesn't ask you a specific way of doing a problem, so graphing comes in handy. But then when I went to problem number 2, I did not do it by, whoops, let me jump over to number 2. I did not do this problem by decimals. And the reason why I'm not going to do them all by graphing. Well, I didn't use decimals. I did graph to solve, but I'm going to do it in a different method also. And let me redo this problem because I'm going to do it 2 different methods. One method by graphing. Remember, we graphed quadratics already this semester. And we called this the parent function. Starts here at 0, over 1 up 1, over 1 up 3. So this parabola looks something like this. Okay? Now, this equation is 2x minus 1. So it starts at -1, and it goes up 2 over 1. So my graph looks like this. It looks like it only hits in one spot. And this is a bad graph because I didn't hit that point. So it looks like it just hits in one spot. So, and that point right there was x equals 1, comma, well, the point was 1, 1. All right, so that's where it hits. Now, let's do it in another method. Let's do substitution, because this to me looks like it works for substitution really nicely, because I know y is equal to x squared. So I'm going to put x squared right here. So I end up with x squared is equal to 2x minus 1. I'm going to get it set equal to 0, so I'm just going to subtract the 2x and then add 1 to both sides. So now I have it set equal to 0. I'm going to factor. What 2 numbers multiply to give me positive 1, but add up to -2? -1 times -1 is equal to positive 1. -1 plus -1 is equal to -2. So x minus 1, x minus 1. So x equals 1. Boom. I get the same answer regardless if I use substitution or I graphed. Okay? Both ways, same answer, doesn't make a difference. Okay? Any questions on that? The graphing or the substitution? You guys okay? All right, let's go to problem number 3 on the practice. Problem number 3, it says, what value of x satisfies a system of equations? Okay, so I'm looking at this, and yeah, it would definitely be x minus 1 squared. Yep, that's exactly right. There's only one solution, right? Because 1 is 1, right? It doesn't. So x minus 1, what makes inside the parenthesis equal to 0? Well, 1 does. Both your parentheses are exactly the same, right? So 1 is going to make both of them equal to 0. So 1 is the only solution it could have. Okay. So now the next problem, I'm looking at it. It's like, okay, I mean, I could graph this thing out. It makes no difference, but I don't want to graph every problem out because I want to practice what we've learned. So I'm going to use substitution in this problem. I know what y is equal to. Y is equal to 3x squared minus 5, so I'm just going to plug it in. I'm just going to plug 3x minus 5 into y. So this gives me 3x squared minus 5 is equal to 2x plus 3. Okay? It's a quadratic. I need to get it set equal to 0. So I'm going to subtract 2x from both sides. I'm going to subtract 3 from both sides. So I'm going to end up with 3x squared minus 2x minus 8. Is that right? Equals 0. All right. This problem right now, I look at it, and it's like, this is not for the faint of heart. Why not? Why is this problem way harder to factor than the other ones? Why is this harder to factor? Does anybody know? There's an a value other than 1, right? Did anybody have me for Algebra 1? I used to teach a method, it's called the cheater method to factoring. Has anybody heard of the cheater method for factoring? Because I would still factor this problem because I know how to factor problems that have values greater than 1 for x squared. Okay, so if I was going to use the cheater method says this. Cheater method says, hey, we're going to cheat. We're going to put whatever this is, we're going to put in the first spot and the second spot. We know that can't be true, right? Because when you do FOIL, if you had 3x here and 3x here, your first term would be 9x squared. It's not 9x squared, it's 3x squared. So this is cheating. So whatever I cheated with, I have to divide out at the end. So I'm going to divide a 3 out at the very end, okay? Because I cheated with a 3, I'm going to divide a 3 out, okay? So now what's the next step? You multiply the outer terms together. So 3 times -8 is -24. And this is where it's exactly the same as the other type of factoring. You have to figure out what two numbers multiply to give you -24 that add up to -2. Okay? So 4 and -6. I agree 100%. That is absolutely correct. So I'm going to put +4 here and -6 here. Now, remember, we cheated with a 3. So we have to divide a 3 out. Well, 3 doesn't divide into 4 evenly, so I'm going to divide a 3 out of this parenthesis. So I'm left with 3x plus 4 and x minus 2. So what are my solutions? 2 and -4/3. That would be factoring. Now, could have used graphing, put it into decimals. Did anybody put this into decimals? Did anybody put 2x plus 3 in and 3x squared minus 5? Okay. Yes, you could plug both of those back in. However, if you take a look at the question, it just asks you what the x values were. So we're basically done on this problem. The x values are -4/3 and 2. Now, if they wanted the whole answer, the ordered pairs, yes, then we'd have to plug in the -4/3 and the 2 into x. But if you take a look at the problem, it just says, what are the x values? So I didn't have to do that. I didn't have to find the y values. Okay, so make sure you read the problems. Okay, problem number 4. Problem number 4. Okay, so you put it in the decimals. See how easy it is to check your answers using decimals? You just plug it in and boom, you got it right away. That's why this week you should all have advanced scores. It might take you a little bit, because you can always check your answer, and if you don't have it correct, remember, you have to show the correct word. You can't just put answers down this week, because I'll say, nope, can't do that. All right, problem number 4, it says, what is the point of intersection of a straight line y is equal to 5x minus 3 and the parabola x squared plus 3x minus 2? What is the point of intersection? Well, the point of intersection is the solution, right? So I could solve this many different ways. I'm going to use substitution, okay? Y is equal to 5x minus 3. Y is equal to x squared plus 3x minus 2. I know what y is equal to, so I'm going to substitute that in. So I end up with 5x minus 3 is equal to x squared plus 3x minus 2. I have to set this side equal to 0, so I'm going to subtract 5x off. I'm going to add 3. Subtract 5x off, add 3. So I'm left with x squared minus 2x plus 1. All right, factoring. Okay, so if I factor this, what two numbers multiply to give me +1 but add up to -2? -1, -1. So x equals 1. So I know that the point of intersection is 1, and it has to be letter B, right? Because that's the only one that has an x value of 1. But I could put 1 back into my equation. Either one of them, let's put into y is equal to 5x minus 3. 5 times 1 is 5, minus 3 is 2. So it is correct. Letter B is the correct answer. And I am talking kind of fast right now. The reason why is because we still have a few more practice problems to go, and I'm taking a look at the time, and I don't want to not give you all of the answers for the practice, because I think the practice probably has a couple harder problems than the assessment does. That's just my opinion. I mean, you guys know what's on the assessment because I showed you what type of problems they are. Okay, so B is correct. Oh, awesome. You check decimals. Okay, and see how easy it is to use decimals to check yourself? It's so easy. Okay, problem number 5. Problem number 5, it says the system of equations y is equal to x squared minus 16 and y is equal to 2x plus 1 can be solved using the quadratic equation. Okay? Yes, it can. But what we have to do is we have to change it into a quadratic equation first, right? So I would use substitution here. I would substitute what I know y is equal to, 2x plus 1, and I'd put it in for y. So that would be 2x plus 1 is equal to x squared minus 16. Then I have to set it equal to 0 because that's the only way you can use the quadratic formula or factor. You have to have the quadratic set equal to 0. So I'm going to subtract 2x off. I'm going to subtract 1 off. So I'm left with x squared minus 2x minus 17. So now I could use the quadratic formula on this equation to solve. I probably would because I'm looking at that equation and there's no way that's going to factor because what two numbers multiply to give you 17 that add up to -2? You're not going to find one. So quadratic equation probably would be the best way of doing this problem, but it didn't ask me to use it. It doesn't ask me to solve. It just asked me to rewrite this so I could use the quadratic formula, okay? But it did not ask me to solve. So this is the equation I would use if I was going to use quadratic formula, okay? So it didn't ask me to solve. It just asked me to rewrite it so I could use the quadratic formula. Yeah, I agree with you. It really was not a very easy question or thing to read through and figure out what they wanted you to do. I think this one's not any better either. It says, in solving the quadratic equation, y is equal to, I'm sorry, it says 0. 0 is equal to 2 times x plus 5 squared minus 16. A student could graph the two equations and find the intersection points. If one of the equations is x plus 5 squared, then the other one is blank. Okay? Does anybody think they got that one? It's kind of a weird one. I mean, I would not ask a question like that, but you could, if you really wanted to solve this using a system of equations, you could, okay? And what I did in this problem, oh no, guys, I just clicked on, okay, there it goes. I thought maybe I was going to lose you guys. Okay, so what I would do on this problem is they're telling me that one of the equations is x plus 5 squared. Okay, that means I've got to get rid of this 2. I got to get rid of this 16. So I'm going to add 16 to both sides. Okay, so I'm going to just rewrite this. So I'm going to add 16 to both sides. So that's gone. So now I have 16 is equal to 2, x plus 5 squared. I'm going to divide through by 2. So now I have 8 is equal to x plus 5 squared. So if this is one of my equations, this is my second equation. So y is equal to 8, and y is equal to x plus 5 squared. If I graphed both of these, I would find the intersection point. So you could do that, but that's kind of a thing that I would not be asking you guys to do. Just, it's kind of one of those. It's like, oh, it's a thinking problem. And now you understand why I wanted to get through all these practice problems today, because some of you would look at that and you're like, what the heck are they trying to ask us on this type of question? So that's why I'm trying to get through the practice problems. We only have one more to go. There's only 7 practice problems, and I didn't know if that was true or false, so I did look. Does somebody have the practice open right now? Is there only 7 problems? That's all I have on my. There are 7. Okay. So the answer was D for the last problem. Yes, you are absolutely correct. It was D. Okay. So here's the last problem. It says solve the system. Now, which way are most of you guys going to solve this one? No, sure, you can do the practice while you're in the e-session. Absolutely. A lot of kids have the two things open at the same time, and then they're done as soon as we're finished. They're done with their practice. Probably substitution. Okay. Now, for those of you that are really truthful, which method are you going to use? Come on. If I was a student and I was going to do this problem, and it's a practice problem, and I don't have to show any of my work, what am I going to do? Exactly. I'm going to plug it into Desmos calculator. Now, somebody said substitution. Awesome. So that's the way I'm going to do it. Somebody please plug it in to Desmos, and let's see if we get the same answers. Okay. So if I'm going to use substitution, I know that negative 4x plus 5 is equal to y, so I'm going to plug that in for y. So I end up with negative 4x plus 5 is equal to 2x squared plus 5x plus 9. Okay. I know I have to have this side equal to 0. Okay, so I'm going to add 4x. I'm going to subtract 5. Add 4x. I'm going to subtract 5. So I'm left with 0 is equal to 2x squared plus 9x plus 4. Okay, what's the problem? Now, what do we have as a problem here? And this is a good problem because now I can show you how to, got to do cheater method. You betcha. So let's review cheater method. I'm going to cheat with a 2x. 2x there, 2x there. So I know I have to divide a 2 out at the very end, okay, because I cheated with it. So now I multiply the two outer terms together. 2 times 4 is 8. What two numbers multiply to give me 8, but add up to 9? Okay, 8 and 1. It's exactly right. So when I factor this thing, I'm going to factor it down to 8 and 1. I have to divide a 2 out of one of the parentheses. 2 doesn't divide into 1 evenly, so I'm going to divide 2 out of here. So that gives me x plus 4 times 2x plus 1. Factored correctly, so negative 4 is a solution, and negative 1/2 is a solution. So I know x equals negative 4 or x equals negative 1/2. Now, can I stop? 4 and negative 1/2. Can I stop? Negative 4, negative 1/2. This is the only answer that has negative 4 and negative 1/2 as my x values. So I probably am going to say this is my answer. Okay, but I could check myself. I could put negative 4 in here. Negative 4 times negative 4 is negative 16. Plus 5 is negative 11. Uh-oh. That does not seem right. Oh, that's, oh. I messed up someplace, didn't I? Because if you put negative 4 in here, negative 16, oh, negative 4, that's positive 16. Nah. I don't know positive, negative numbers. Negative 4 times negative 4 is positive 16. So it does match up. So it should be, so letter C should be our correct answer, shouldn't it? Did somebody put it into Desmos? Did you get negative 4, 21 and negative 1/2, 7? Did it work? Did we get the same answers? All right. Oh man, with 2 minutes to spare. Thank goodness we only had 7 problems on this week's practice, because I think if we had any more, we wouldn't have made it. I apologize because I did start when there was no students in here because, you know, I knew Blackboard wasn't working. I was in. So if you do watch the recording, you're going to end up watching it probably twice because it's going to go over the same thing 2 times. Sorry about that. It's just the way it happened. What's number 1 on the practice? Again, I went through it. I think, oh no, what am I doing here? I got to go to problem number 1. Number 1 was 2 solutions. The graph, it crossed twice. So there were 2 solutions, so the answer was C. Okay, remember, if you're struggling with this stuff, we have a help session on Wednesday afternoons at 1 o'clock. Please participate. It's always a good time. You guys have a good week. Bye.